In this video, we're going to take a detailed look at the parameters available in the Transformer Data section of the TAPCON 230 Basics Web HMI interface. To access this section, follow this path: Settings, then Parameters, then Power Grid, and finally, Transformer Data. The parameters found here allow the TAPCON to correctly interpret the voltage and current signals coming from measurement transformers and use them to calculate and display electrical values in primary magnitudes. Let's start with the voltage settings: primary transformer voltage and secondary transformer voltage. These two values define the voltage transformation ratio used to scale the measured signals. The primary value represents the nominal high voltage side of the voltage transformer. That is, the actual system voltage. The secondary value is the nominal voltage delivered by the transformer to the TAPCON's input terminals. For example, if we have a VT rated at 10,000 volts to 100 volts, we should enter 10,000 as the primary value and 100 as the secondary value. This way, the TAPCON can compute the primary voltage by multiplying the measured value by this transformation ratio. Now, let's continue with the current parameters: primary transformer current and secondary transformer current. These work in exactly the same way as the voltage parameters, but for the current signal. For example, for a CT rated at 2500 amps to 5 amps, the primary value would be 2500 and the secondary would be 5. Now let's look at the voltage transformer circuit setting. This parameter defines how the TAPCON interprets the voltage signals it receives. The available options are: single-phase phase voltage for single-phase systems, three-phase phase voltage for three-phase systems with phase to neutral measurements, and three-phase differential voltage for three-phase systems with phase to phase measurements. This parameter does not affect the primary voltage calculation, but it does impact how active and reactive power are calculated, what voltage units are shown in the HMI, either phase to phase or phase to neutral, and how the TAPCON interprets the network topology. Now let's look at the current transformer circuit parameter. This defines how the current signals are wired. The available options are: single-phase phase current for single-phase systems, three-phase phase current for line current measurement in three-phase systems, and three-phase total current for differential measurements, where the signal is the vector sum of two line currents. This setting does directly affect the primary current calculation. In three-phase total current mode, the TAPCON divides the measured signal by the square root of 3 to estimate the equivalent line current. It also impacts the calculation of active, reactive, and apparent power. The last parameter is phase angle correction, which lets you input a correction angle between the voltage and current signals. This is important when there are phase shifts caused by the topology of the measurement transformers, such as transformers connected in delta or differing physical locations between the VT and CT. By correctly setting this angle, the TAPCON can accurately calculate active and reactive power, power factor, and the direction of power flow. For example, if the connection of the current transformer introduces a 30-degree phase shift, you can enter that value here to correct the system's readings. As we've seen, all of these parameters are essential for the TAPCON to correctly interpret the electrical signals around it and calculate values in primary magnitudes. In the next video, we'll carry out a practical demonstration using secondary injection to observe how these configurations impact real-time readings and system calculations.